In our previous video, we looked at a way to use something called synthetic division to divide two polynomials. What we're going to do in this video is use synthetic division to not only divide a polynomial, but also to go ahead and then use that to factor the polynomial. So here's how this is going to work. We are given a polynomial that we want to divide, and we're given a factor, what we're going to divide by. Now, because we know we have a factor, we know our remainder is going to be 0. That's what it means to be a factor. We have nothing left over. It goes in evenly. So let's do synthetic division and start this problem the same way we've started the ones in the previous video. So take what you're dividing by, and remember the way the synthetic division process worked was we had to change the sign of that factor. So if x plus 2 is the factor, negative 2 is what's going to go in the box. Next to that, I'm going to list my coefficients in order, noting any terms that might be missing. If I'm missing a term, I need to put a 0 in its place. In this case, I can see that my terms are in descending order. They start with the highest exponent, end with a constant, and there are no terms missing, so I don't need to include any zeros. A quick refresher of synthetic division if you don't remember. First term drops straight below the line, so the 3 just drops. Take the number below the line, multiply it by what's in the box. So 3 times negative 2 is negative 6. And then add those values together. Negative 4 plus negative 6 is negative 10. And repeat until you run out of numbers. So now negative 10 times negative 2 is positive 20. Add those values together, get a negative 8. Negative 8 times negative 2 is positive 16. And then add those values together, we get 0. Remember that last number always represented our remainder, and we knew this time, as we stated at the beginning, we knew that remainder had to be 0 because we were told this was a factor. If we didn't end up with a remainder of 0, then something went wrong. So here's what our answer represents right now. I've got 3x to the second power. Remember, you're always one power lower than where you began. The problem began with x to the third, so we're at 3x squared now, minus 10x. And then minus 8. There is no remainder. What I'm going to do though is I'm going to put that in parentheses, and next to it I'm going to write what I was dividing by, the x plus 2. Since this has gone in evenly, I know if I multiply those two expressions together, I'd end up back where I started with that 3x cubed polynomial. So what I've done is I've really factored this. Notice though, the piece that we just found, the 3x squared, we can try to factor that again using techniques we learned in the previous unit. So that's what I'm going to try to do to factor this polynomial completely. So I probably start by looking for a greatest common factor within that trinomial. There isn't one, and since there's not a 1 in front, I'm going to have to use the box method to factor this. So quick refresher on the box method if you don't remember how to use it to factor. Take your first term and put it in the first box, your last term in the last box, and then multiply those values together. They multiply to negative 24. So what I need to do is finish filling out the box with two numbers that multiply to negative 24, and at the same time add up to negative 10. So take a second, pause the video if you need to, think about those values. Have you found them yet? Have you paused the video? Those two values you came up with, hopefully, were negative 12x and positive 2x. Now it doesn't matter where they go in the box, but do make sure the 12 is negative and make sure they both have x's. To finish this then, we are looking across rows and columns for greatest common factors. Negative 8 and negative 12 can both be divided by negative 4. It's the biggest number they both have in common. 3x squared and 2x along the top row, they only have an x in common. Do the same thing up and down columns. So 3x squared and negative 12x have a 3x in common. And then finally 2x and negative 8 can both be divided by 2. So what that means is that trinomial can be factored into 3x plus 2 times x minus 4. And if we include the factor they gave us, x plus 2, we've now factored that original polynomial, that polynomial to the third power, we've now factored it completely into 3 separate factors. Our next problem is almost identical to what we just did, using synthetic division to factor a polynomial. However, this problem adds one extra step to it. They want us not only to factor it, but also to find the zeros to solve. So we've done this before. Once we factored it, we drew lines between our factors and set each one equal to 0. So we have one extra step this time. One other difference right off the bat is that this time they've given us a 0, not a factor of the polynomial. How that differs with synthetic division is if they give you the 0, you don't change the number. You leave the number as is. So negative 2 is what goes in the box. We're not making the opposite. We only do that if we're given factors. So in this case, just make a note of that does not change. Everything else will be the same, so list out your coefficients. You've checked that they're in order, you've checked that nothing's missing. right? It's true this time nothing's missing, they are in order. And then we do synthetic division as we've always done. I know my remainder has to be 0 because they're telling me this is a 0, this is going to work. If I don't get a remainder of 0, I've done something wrong. So drop the first number straight down below the line, multiply by what's in the box. So -2 plus 2 gets me 0. Ooh, look, there's a 0 elsewhere besides the remainder. That's okay, that's totally fine. 0 times -2 is 0. Add those up, I get -9. And finally, one last time, do -9 times -2, positive 18, and there's my remainder of 0 as predicted. So what these numbers represent then are the polynomial x squared. I can skip over the 0x and just go with -9. So let's write this in factored form. So that's what I got when I divided. I was originally dividing by, actually no, I changed my mind, don't worry about that. Let's just go ahead and factor this. So at this point, I can use something called difference of two squares. Hopefully you remember how to do that. Otherwise, the way it worked to factor difference of two squares was we had two sets of parentheses, and it came down to doing square roots. So the square root of x squared is just x, put that in the front spot. The square root of 9 is 3, so that goes in the back spot. And the only difference was one was plus and one was minus. Now, the problem has been factored all the way. However, they didn't ask me just to factor it, they asked me to solve this. And so I want to do one more step. To find the zeros. I want to draw the line between my factors and then set each one equal to 0. So either x plus 3 is equal to 0 or x minus 3 is equal to 0. If I finish this, I get two solutions right here. -3 is going to be a solution. That's going to be one of the zeros of this. And then +3 is going to be another solution. There's a third solution as well, and that's the one they gave me at the beginning, so I might as well go ahead and list it just so they're all three listed. So x equals -2 is also a 0, that's the one they gave me. So there's our three zeros of this. Now, you heard me sort of like stutter a little bit before when we were talking about factoring x squared minus 1. The reason I didn't want to list that, we can list it now, is I kind of want to go backwards. And if I think about this, if -2 is my solution, what I want to know is what would have been in that parentheses. This is kind of thinking ahead to something that's coming up in a little bit later. But we might as well think about it now. It's an easy thing to talk about. So I think you guys have seen the pattern already. If I'm going backwards to get a solution of x minus 2, that means x plus 2 must have been that other factor. So that's why I didn't want to talk about that before. I just figured I'd save it for the end. It's not super important for this problem, but a good thing to talk about for what's coming up. They asked me for the zeros, and there are my zeros. -3 and 3 were the ones we found, and -2 was the one they gave us.